Dear students, in the course of high voltage engineering, the basic things we need to discuss: high voltage transmission, advantage need for generation of high voltage in the laboratory, electric field testers, how the breakdown mechanism will take place in gases, vacuum, liquids, solids and composite electrics. So in this video we are going to see about how the vacuum breakdown will take place in detailed manner. Okay. Previously we have discussed about the breakdown mechanism takes place in gases dielectrics. So vacuum is also one kind of dielectrics, that is medium. We are going to use it for the insulation purpose. According to the Townsend theory, in gas medium, the growth of the current in the gaps depends on the drift of the charged particles. The absence of such particle in the gas medium, the same in case of the perfect vacuum, there should be no conduction and the vacuum should be a perfect insulation medium. But practically, due to the presence of metallic electrode and insulating surfaces within the vacuum, that will create a complicated issue that will produce a breakdown. So that is due to the very high voltage that leads to the breakdown. First we are going to see about what is vacuum. Vacuum system, which is used to create vacuum in a system which the pressure is maintained at value much below the atmospheric pressure. In vacuum systems, the pressure is always measured in terms of millimeters of mercury. One standard atmospheric sphere is equal to 760 millimeters of mercury at a temperature of 0 degrees Celsius. The term millimeter of mercury has been standardized as torr by the International Vacuum Society, where 1 millimeter of mercury is taken as equal to 1 torr. Now we are going to see about the classification of vacuum. For electrical insulation purposes, the range of vacuum generally used is a high vacuum in the pressure range of 10 to the power minus 3 torr to 10 to the power minus 6 torr. Basically, high vacuum, very high and ultra high vacuum. The millimeters of mercury in terms of torr, we are going to use it for the high vacuum is used for the insulation purpose compared with the very high and ultra high vacuum. Okay, now we will see about how the vacuum breakdown will take place. Okay, in the Townsend type of discharge in gas, electron gets multiplied, that is due to the primary and secondary ionization process. The electron avalanche will be formed in a high vacuum. So in the category only we are going to use it for the vacuum as a insulation property. In high vacuum, even if the electrodes are separated by a few centimeters, an electron crosses the gap without encountering any collisions. Therefore, the current growth prior to breakdown cannot be due to the formation of electron avalanches, as in case of gaseous medium. However, if a gas is liberated in a vacuum gap, then the breakdown will occur in the manner described by the Townsend process. The same manner, the breakdown will take place even in the vacuum medium as well. There are different mechanisms for breakdown in vacuum are particle exchange, field emission mechanism and clump theory. First we will see about the particle exchange. So this is actually vacuum medium. We are going to keep electrodes, cathode and anode with a distance, smallest distance. We are going to apply very high voltage where the electrode will be curved shape. So consider here the particle exchange mechanism. First we are going to apply the very high voltage. The electron will be liberated from the cathode to the anode. So the huge number of electrons will be particles are accelerated due to the very high voltage applied to the electrodes between the electrodes. So the electron will be released from the cathode and moving towards the anode. So then again produces photons and positive ions. So this kind of exchanging the mechanisms, that is called electrons, positive ion and photons, and the absorbed gases at the electrode surfaces. Qualitatively, an electron present in the vacuum gap is accelerated toward the anode and impact releases the positive ion C, A positive ion and C photons. See, we are going to take A positive ions and C number of photons. Then the condition for breakdown we are going to consider. So D is the number of photons liberated by D electrons. So the condition for the breakdown is AB plus CD is greater than 1. We are getting the breakdown condition for breakdown, exchanging the particles between the electrode surface. The second one is field emission theory. It consists of there are two mechanisms, anode heating mechanism and cathode heating mechanism. So due to the application of high voltage, the electron will be released from the cathode and moving towards the anode. Due to the impact of electrons on the anode, that will produce the vapor cloud and heat the anode. So this is the surface of the anode will be bombarded due to the huge number of electrons and space charge formation. The vapor cloud will be formed that will heat the anode. That is nothing but anode heating mechanism. So this process will continue until a sufficient number of electrons to give rise to the breakdown. The second one is cathode heating mechanism. After the bombardment of electrons released from the surface of the anode, then the electrons move towards the cathode, and the formation of vapor cloud on the cathode surface that will produce the heating the cathode. So this is nothing but cathode heating mechanism. The third one is clump mechanism. So it is considered as the surface of the cathode is cavity. It is that area, the loosely bounded clumps will be detached due to the very high voltage that will move and accelerated across the gap. The breakdown occurs due to the discharge of the vapor or gases released by the impact of particles at the target electrode. So this is actually clump theory. We consider there are three diagrammatic representation. The first figure represents the cathode and anode. We are going to apply for the very high voltage between the electrode. The loosely bounded particles attached in the cathode where due to the high pressure that will be completely detached from the cathode and move towards the anode. The clump is detached from the cathode surface and accelerated across the gap towards the anode. Due to the impact on the anode, gives the cloud of metal vapor. So due to this leads a breakdowns. This is kind of a clump mechanism. So far we have discussed about the breakdown mechanism, how the breakdown mechanism will be takes place in vacuum. Okay, I hope you understand very well about the breakdown mechanism takes place in vacuum medium. Thank you.